All right, in example 5, we are translating verbal statements. So, in A, x is more than 3. So when x is more than 3, I know that it has to be greater than 3. So that would be x is greater than 3 like that. X is at most 3. So the biggest number it can be is 3. So that would be the opposite. It's less than, but it's also equal to since 3 is a solution. X is at least 3. So if your parents say you can have at least 3 friends over, you can have 3 or more friends. This would be greater than or equal to 3. X is no more than 3. So 3 is the limit there for that one. So that would be anything less than or equal to 3. And this last one's a little confusing. It's at least 10, but no more than 16. So it's anything bigger than 10, but has to be less than 16. So I would like to put x in the middle, and if it's at least 10, I know that x is going to be greater than or equal to 10. So writing it this way would be 10 is less than or equal to x, but no more than 16 would be less than or equal to 16 like that. So at least 10, but no more than 16 would look like a sandwich and compound inequality. All right, now to your favorite, applications. So your company requires you to select one of two payment plans. One plan pays straight $3,000 per month. The second plan pays $1,000 per month plus a commission of 4% of your gross sales. Write an inequality for the gross sales per month for which the second option yields a greater monthly wage. So the second option is this one right here. And we are trying to find the amount of sales where the second one would be greater. So the second plan is $1,000 per month plus a 4% commission. We need to take 4% and change that to be in decimal form. So that would be that would be 0.04 x, and x is going to be sales. So this inequality represents the second plan. The first plan is just $3,000 per month. All right, so this is the second, this is the first. And we want the second option to be greater than the first. So here's the inequality I can create. 1,000 plus 0.04x is greater than 3,000. So the first thing I'm going to do is subtract 1,000 from both sides. I'm left with 0.04x is greater than 2,000. Lastly, I'm going to divide both sides by 0.04. And I get x is greater than 50,000. So your sales have to be more than 50,000 for the second option to be better. If you think you're ready for the second one to do this on your own, please pause the video and try the second. All right, let's go over the second one. So Company A rents a subcompact car for $240 per week with no extra charge for mileage. Company B rents a similar car for $100 per week plus an additional 25 cents for each mile driven. How many miles must you drive in a week so the rental fee of Company B is more than that of Company A? All right, so X is going to be number of miles. I can see that from the question here since it's asking for how many miles. And we want Company B to be more than that of A. So let's create the expression for Company B. Company B rents a similar car for $100 per week plus an additional 25 cents for each mile driven. That would be 100 plus 0.25x. And we want Company B to be more than Company A, which is just a straight $240 fee. Doesn't matter how many miles you drive. So this would be the inequality we would create. Step 1, we would subtract both sides by 100. We get 0.25x is greater than 140. Step 2, we would divide both sides by 0.25. get x is greater than 560. That means anything more than 560 miles. All right, if you think you're ready for a challenge, press pause and try the next one on your own. All right, let's go over the next one. Your company wants to earn a profit. In order to obtain a profit, the revenue must be greater than the cost. So revenue must be greater than the cost. Revenue is the amount of money earned from selling X units. For what values of X will this product produce a profit if R is equal to this and C is equal to that? So basically we just have to replace in the little expressions for each variable R and C and then solve. So I have variables on both sides. So what I'm going to do is move the 61x to the left by subtracting both sides by 61x. And when I subtract 89.95 minus 61, I get 28.95x is greater than 875. Now I'm going to divide both sides by 28.95. And 875 divided by 28.95. I get here x is greater than 30.2245. It keeps going. So for what values of x will this produce a profit? So it has to be more than this number. And because we're selling a number of units, this one's a little bit interesting because I know this would round to 30 most likely. But if I put 30 in for these variables and I do 89.95 times 30, I'm going to get a revenue of $2,698.50. And if I put in 30 in for X here, 61 times 30 plus 875, my cost is $2,705. My cost is more than my revenue, so this would not be a profit. So 30 actually is not going to work. Anything greater than 31 is going to be the answer where my revenue is more than my cost. If I replace 31 in for X here and here, you'll see that the revenue is more than the cost, and that's what we are looking for. What I want you to do now is if you do have a Griffin calculator, on the next page, I want you to try the investigation by hitting these buttons and solving this with your calculator, which would be really helpful. If you don't have a Griffin calculator, please skip that and then try these 5 practice problems by solving them on the side here. There might not be enough room, but you can use a separate piece of paper.